Okay, this should look like a box. Okay, think of it as a box that might contain your shoes, or it might contain a toy, or it might contain something that just arrived from Amazon Prime Time. Now, the goal is, where are you standing? Now, the black in the front, okay, this is known as standing in front of the black side of this box. This is known as the front side of the box. You only see that black box. Now, if we walk around to the back is going to be the blue side of this box. It's in the back. Okay. We then have a top side. Now the top is going to be this highlighted yellow area. This is my top. That's the top. The yellow side is my top. Now, this green highlighted side okay, this green part is known as the bottom of the box. That's the green side. This is the green side. Now, we happen to have 4 side pieces, or at least 2 side pieces. Okay. This pink and this pink are known as sides. Okay, so for every box, we have a front side, a back side, a top, a bottom, and we have sides. Okay. Now the sides are the pink area, and that's kind of hard to see with this type of figure, but this is what you have to think. We are going to be talking today about volume and surface area. Now, we're going to be using pictures. Most of the pictures are going to deal with what I call little sugar cubes. And we're going to stack these sugar cubes in various ways. But remember, each little sugar cube has a front, a top, a bottom, a back, and sides. That is how you are going to determine what we need. And notice, when we talk volume, volume is going to be the water or liquid in a fish tank. Volume talks about liquid inside a three-dimensional object. And an example would be water. Or think of all those juice bottles that you drink. The water inside is volume. Now, surface area, okay, is going to be the wrapping paper around a box, or the material that makes the box. Lateral is also another type of area, and you are going to be seeing that. But in this case, we have volume, okay, come on. And notice it's in cubic units. It is the liquid inside. Surface area is the wrapping paper that goes around the box. Now, area is always square units. Okay. Now, another word that they're going to talk about is called lateral area. This is the label created for the 3D object. Lateral area is not surface area, but it is part of the surface area. Lateral area is going to be the label on the can. Lateral is L, label. Surface area is all of the material that makes the 3D object. Now, when you look at these next couple of slides, if you have difficulty seeing what I'm going to be talking about, it's normal. Most people who are not familiar with looking at the object in three-dimensional view, it takes a little bit. But hopefully I'm going to be able to help you figure out what they want. Now, this is another box, but this box is made up of a lot of little sugar cubes. This big box in blue is going to be made up of tiny little sugar cubes. Now, just like we're going to be doing, they are going to have you look at a figure just like this, and they are going to ask you to find the volume and the surface area. we do each differently. Now, on this figure, they are going to be talking about a face. A face is one of the sides of the figure. This face, as you see, is kind of outlined in red. That is a face. And if we were standing right here, what is in front of us? This red area would be my front view. I'm standing right here in the orange. I'm looking at this box created by sugar cubes. I'm looking at the face or the front view of this box. Now, your book is also going to talk about layers, which means every layer or most layers have the same number of sugar cubes going across, but it also has the same number of sugar cubes most of the time on each level. So the layer, which you see highlighted in blue, is one layer. Now, the face we're looking at, where this layer is, that means if I stand over here, this face is known as the side view. And the side view has 3 layers. This is layer number 1. This is layer number 2. This is layer number 3. Now, each layer has 3 sugar cubes. Okay. So when I look at the first question, it says find the volume. Well, by using this picture, I know that I have 3 layers. All 3 layers together have 9 cubes. Notice this black layer that's highlighted in blue has 3. The second layer has 3 again. The third layer has 3 again. And I have 3 layers. Each layer has 9 cubes. And think about looking at the black top. This top has 9 cubes. To make that top, I have 9 little boxes showing. The layer has 3. So 3 times 9 gives me 27 cubic units. This big box is made up of 27 little sugar cubes. That's what you have to think. You have to try and see the little sugar cubes. There are 27 sugar cubes that make this big box. So that is what I'm looking at. 3 layers. Each layer has 9 sugar cubes. And notice cubic. Cubic is 3. Now, we also want to find surface area. A little bit different. We're still going to the top. We have 9 boxes showing. But if you look at the front view, that means we're standing right here and we're looking toward the face right in front of us. We have 9 boxes. If I look at the side view, there are 9 boxes. Now, I know you can't see it, but back here is the back side of the box. That back side has 9 cubes, or 9 little squares. This side view has 9 boxes. But don't forget, I have a bottom. What is this big box sitting on? It's sitting on 9 boxes. So each face has 9 boxes. There are 6 sides of this box. The 6 comes from the front, the back, the top, the bottom, and I have 2 sides. 6 sides. When I multiply those together, it will tell me that I have 54 square units, because each square, I'm looking at the top, the side, the back, the bottom, the front, they all have 6 different faces. So there's 9 boxes per face times 6 sides of the box. Okay. Now, this is what we're looking at. And I'm going to see if I could spell it out for you a little better. Volume, which I'm going to use as the letter V, equals number of layers times number of boxes on a face. That's what you've got to think of. This volume is going to be the number of layers, that's what the 3 is, times the number of boxes on a face. Pretty easy. The surface area, and they sometimes call it capital SA, is equal to the number of boxes on a face times the number of faces on this box. Surface area, volume. Now, are there any questions before I go on? Okay. This little figure you see in front of you in the blue box is the simple one. The next 4 slides are going to ask you for different things, but they're not going to be as nice as this nice little box. Now, this is the figure we are looking at. Okay. Now, this is something you're going to have to consider. This figure is basically created by 2 different sets of sugar cubes. Now, the goal is to make sure that you understand what this figure is composed of. Now, I'm going to take and tell you that this yellow area is one part of this big box. I have the green part. This green part is the second part of the box. I am putting the yellow and the green together. So when I want to find the volume, I need to think of this in 2 different parts. The yellow, okay, and the green. Now, your book wants you to consider layers, okay? Well, if they do that, okay, I'm going to let you know that, doop, okay, okay, we, let's see here, okay, we can also look at this as all of this green stuff being what we call layer 1. Okay. That's the bottom. And this part that's still left up here, atop of the green, this is known as layer 2. Okay. So we have one big green area, but you've got to remember to put layer 2 atop layer 1. We have some hidden green sugar cubes. Okay. Now, the key here is volume. Okay, layer 1, it has, and we're going to count these things, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, Okay. We have 16 boxes showing here. So for our purposes, the green is showing me 16 boxes in the green. So I have in layer 1 16 boxes. I just counted them. Now, in this part right here, hidden below, I have green boxes. Now, I have 1, 2, 3, 4, 5, 6, 7, 8. But I have 2 layers of 8. 2 layers of 8, which means my volume is going to be 16 boxes plus 16 boxes, which gives me 32 units cubed. The green I'm looking at all by itself. That has 1 layer. I count the boxes. There are 16 boxes in that green area, but there's only 1 layer of them. When I go to layer 2, notice I went to the top of layer 2. I count 8, but I have 8 sugar cubes stacked atop 8 other sugar cubes. There are some sugar cubes that I can't see, and that's where the difficulty comes in. You can't see them, but you got to know they're there. I have 8 cubes in the top and the bottom, which is where this 2 comes in. Now, remember, assume that there are boxes you cannot see. That is the difficulty. Now, I don't want to go any further if you have questions, because we're going to build on this. Okay, this is volume. Well, let's change the figure a little bit. Ooh, look at what I have. Okay, I am still being asked to find the volume. But this is where you have to realize this is 4 parts. This part is going to be counted. But this part is going to be counted. And then we have this part. And then we have this part. Okay. We have a green, we have an orange, we have a blue, we have a red. To find the volume, we're going to go to the top of the green. Okay. So the green happens to have 1, 2, 3, 4, 5, 6, 7, 8 boxes. And they are 1 layer times 8. That means I should see 8 boxes. They're the easy ones. Now we're going to go to the orange. Now the orange, we're going to go to the top and we're going to count. 1, 2, 3, 4. But notice I'm putting X's over here. We have 2 layers. There are 4 boxes, a top of 4 boxes. I can't create without the bottom layer. So this is 2 layers times 4 boxes, which gives me 8. Now I'm going to the blue. Well, again, I'm going to the top. I have 1, 2, 3, 4 boxes on the top. But I have 1, 2, 3 layers. Okay. So that means 3 layers times 4, which gives me 12. Okay. And then let's go to the red. Okay. Count the top. 1, 2, 3, 4. So I have 4 boxes, but I have 1, 2, 3, 4 layers. Layers. Boxes. This gives me 16. Now, if I add all of these together, this will give me the volume. 16, 18, 24, carry 2. I have 44 units cubed. Does everybody see how I found the volume? Okay. Now, this is where it gets a little interesting. Okay. Surface area. Surface area. Okay, this one is going to be a little different. Okay, you need to realize this figure has 6 faces. 6 faces. Surface area has 6 faces. Now, we're going to do this in parts. When you talk surface area, you are going to have to consider the faces. This is front. This is back. Down here is bottom. Up here is top. And then we have the sides. Okay. This is a side. But remember, there's another side in the back. The front and the back are going to be slightly different. But the sides, you're only seeing one side of this figure. But there's an identical side on the back. You need 6 faces. Okay. Now, with that said, okay, we are going to do each face. So what we have is the front has, okay, you are standing here. This is where you're standing. Your front are these boxes and these boxes. That's what you see from the front. Now, how many boxes are there? Well, the front happens to have 1, 2, 3, 4, 5, 6, 7, 8. That is your front. Your front has 8 boxes. Now, the top and the bottom are going to have the same number of boxes. That's the beautiful part about it. The top and the bottom will have the same number of boxes. Now, the top is up here and up here. This is the top. If you're standing here and looking down, all you're seeing is the yellow. Well, the yellow, Chrissy?
So how do you know, how do you determine which part is the front?
Okay, normally you have to make a choice. The front normally is to the right of the figure. the back is to the left. Now, sometimes they tilt it a little bit, but you have to begin by choosing the back and the front. It's just a perspective view. Think of yourself as an artist. You have to decide in your drawing, what are you putting up front? What are you putting in back? Or what do you want the person viewing your art to see? Front and back is your choice. But normally, as you see what I have here, the front is going to be the right side of the figure.
So then would it
You
usually be okay to just choose like the shorter end for your front?
correct. That would be a good way to go.
Okay, thank you.
Anytime. Okay, now let's count the top yellow boxes. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I have 24 top boxes, but I also have 24 bottom boxes. Now, are there any questions with why the top and the bottom are the same? These are my top boxes. I'm looking down at something. When I look down, all I see are yellow boxes. Now, let's look in the back. Okay. Okay. Now, the back you normally cannot see, but you have to kind of isolate in your mind that the back is going to have 2 layers. It has this layer and this layer. Each layer has the same number of top boxes. So in this case, to find the back, I know that I have 1, 2, 3, 4, and in this case, I have 2 layers. 4 times 2 tells me that my back side has 8 boxes. There are 8 in this back. Okay. And also notice front and back, same number. Top and bottom, same number. The sides, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 in the front, 8 in the back is 16 boxes make the side view. I have a front and a back. Now, if I add 8 plus 24 plus 24 plus 8 plus 16, I will get my surface area, which is 80 units squared. This is the counting of the boxes. They are trying to teach you to use what we call an artistic perceptive view. Okay? Sometimes they call it 1, 2-dimensional views. Artistically, you are seeing dimensions. In a surface area, you must see all 6 faces or sides of the box. Okay. Now, are there any questions with this one? This was my surface area by my counting. Now we're going to do it again, except I'm going to change the figure. Not much. Now, Chrissy, I am choosing this to be my front. And back here is my back. My top is this view. My bottom is what's underneath. And then I have my sides. Okay. Now, we're going to do some counting here. We know that the front and the back will have the same number of cubes. Well, this is my yellow part. Or let's make it green. This is my front. This is my front. This is my front. This is my front. If you think about stairs, and maybe many of your houses have stairs, if you stand at the bottom of the stairwell and you just look straight in front of you, you are going to be seeing what they call the rise of the stair. What makes the stair go up? That's the green part. The front is going to be the rise. Okay, the front part is the rise in the stairs of your staircase. That's what the front view is asking you for, the rise. Well, let's count them. Okay, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. My front shows 16 boxes, and sure enough, my back is going to have 16 boxes. Okay. Now, my top and my bottom are going to have the same number of boxes. If you stand at the top of your staircase and you look straight down, you don't look diagonally, you look straight down, all you are going to see is this level, this level, this level, this level, this level. Your orange is what they call as, it's the step part. And I forgot what they call it. It's rise, over, run. Okay. The top is known as the run of the stair. Run of the stair. What you step on. That's what the top is looking at. What your feet are stepping on. You don't see depth. You just see where your foot is going to walk on. Well, we're going to count those. And I'm going to make little X's to make it easy. Okay. I have, ooh, let's make it black. I have 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 top, and at the bottom, I have 20 as well. The top is showing me, if I look down, just where I'm putting my foot. But the bottom is all of those orange that makes the bottom of the stairs before I even climb. Now, I have 2 side views. Those are the ones that I don't have shaded. They're not green and they're not orange. I have how many of those? Well, I have, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 that I can see, but you have to remember I have 11 back here on the other side. Okay. Now, if I add all of these together, I will come up with 94 units squared. That is my surface area. Now, are there any questions? Now, you see that I used a highlighter. You might find that a highlighter for you will work well. Surface area has 6 faces. You count the faces. Okay. Surface area has 6 faces. The front and the back, the top and the bottom, and the two sides have the same number of little squares. So if you can find the front, you can find the top, and you can find the side, you know the back, the bottom, and the back side because the numbers are doubled. Now, with that said, this is part of what you will see when you do your homework for 217. There are a few of these. You're going to have to count the boxes. I can't do anything about it. But notice how I did it. If you have trouble, try highlighting and then counting. Because the rest of these formulas are given to you. You don't have to look at a picture. You just have to use the formulas. And the formulas are using an old friend. Exponents. Yay! And let's show you before we take a break. This is considered a cone. Okay? They are going to give you the formula. Oh, how nice of them. It's right here. Yay! The formula is right here for you. The only difference is you have to know that the R in the formula is equal to the radius, and the H equals height from top of cone to the center of the circle base. As long as you know those two things, life's easy. Now, they are going to ask you to write this answer in a couple of different ways. Okay. Now, it's going to say, write your answer in pi. Okay. Well, to write your answer in pi, we have the formula V equals 1/3. Now, we're going to put pi over 1. And then we have 2 R's and 2 H's. This is an R, this is an R, and that's my H. My radius is 4 over 1, 4 over 1, and 6 over 1. When they want you to write your answer in pi, you are getting a fraction. That means you're going to take all of the numerators, this 1, this pi, this 4, and this 6, and you are going to multiply them together. But you're only multiplying the numbers. This will be 96 pi. Then you take all of the denominators and multiply them together. Well, it's 3 times 1 times 1 times 1 times 1. Now, this fraction has to be reduced because I can divide or reduce by 3, which gives me 32 pi centimeters cubed, or cubic centimeters. That is your answer in pi. Now, if they want you to write your answer to the nearest hundredth, that's a decimal. TH after the word hundred is decimal. 2 decimal places. Now, do not use 3.14. You have got to use your pi key, because you can be slightly off by 1 digit, and no matter what you do, Pearson's not going to take it. It's got to be your pi key, which is 32 times your pi key, and this will give you the decimal of 100.53 centimeters cubed. Decimal pi. And you will see that happening. Read the instructions and give them exactly what they want. Any questions? Okay. Here we go. We got the formula. Well, this is, now they're talking about surface, but you have to remember when they just write find the surface, they are asking for the surface area of the sphere, or the material that makes this sphere. That's what surface area is. Think of a beach ball. All of the plastic that is made up of the outside is surface area. Well, the formula is really easy here. Okay, we are going to write our answer in 2 ways. Okay, we are going to write your answer using pi, and then we're going to write our answer to the nearest hundredths. Okay, that means I want a decimal. Well, here we go. This will give me S equals 4. This is pi. And remember, the R says I have 2 of them. This is 2. This is 2. Well, my pi answer is taking the 4 times 2 times 2, which will give me 16 pi units squared. Surface area, area is always 2. That's the exponent. But if I want to get it in hundredths, this will give me 50.27 units squared. 50.27 units squared. Okay. Now, this one. Okay. Okay. Formula time. We are talking volume. Well, this one is pretty good, okay, because the formula is saying volume equals 1/3 times length times width times height volume, volume. Okay, that's my formula. Well, I have a fraction, and the nice part about it is there is no pi with this. So therefore, you are going to look and see I have a 12, a 7, a 5. The 12 has 2 digits. Because it has 2 digits, this answer will be rounded to 2 decimal places, which means I now have V equals 1/3. Now my length and my width are on the ground. There's what the pyramid stands on. This is 7 over 1. This is 5 over 1. And my height is 12 over 1. Well, if you notice, you can take this 3 and the 12 way back here, because I'm multiplying all 4 of them together, and I can cross cancel. Now, if you don't recognize that, that's okay. You will still get the same answer if you take 1 times 7 times 5 times 12 in the numerator and 3 times 1 times 1 times 1 in the denominator, and you will still get 140 units cubed. Okay. Any question with this? Okay, I'm going to stop here. I have 2 more slides that will finish 217, and they are some story problems. Yay! But they have some old stuff that we've done before. You just have to know how to use it in the new stuff. So we're going to stop here. I will see you at 9 o'clock, and we will work on the last couple of slides in 217, which will finish cycle 2 today. And maybe after break, I'll start cycle 3. See you at 9 o'clock. Yay!